Hey there! Welcome to the wrap-up of probability, where we will talk about combinations. This is sort of a continuation of the last lesson on permutations, because combinations are somewhat related. All right, let's see what they are. Combination is arrangement of items where the order doesn't matter. Permutations, you were worried about lining things up, and if you switched the order around, it was a different lineup, so it had to count differently. Well, in a combination, you switch the lineup around, and it doesn't matter. It's still the same combination. So the numbers are a little different when you're trying to figure out how many combinations are possible. And it's really important to analyze your problems and ask yourself whether or not order matters. As we do some of the problems for combinations, I'm going to keep talking about the fact that order doesn't matter, and that's why we're doing combinations. Now, for combinations, there's a formula, just like there was for permutations. And notice that that formula looks a lot like the permutations formula. If you take the n factorial over n minus r factorial and look at that very carefully, that is the permutations formula. But notice that there's another part down here in the denominator. You're also having to divide by r factorial. Well, because order doesn't matter, you have to eliminate those different quote-unquote arrangements where you had the same items, but just switched them around. Because in combinations, that doesn't matter. It doesn't count separately. Same items switched around are still the same in a combination. So you have to divide by r factorial to account for that. Okay, so yeah, that combinations formula is basically that combinations formula of n choose r. So you have n items and you're choosing r of them. You're trying to figure out how many combinations are possible. It's basically the permutations formula in PR over that r factorial. That's basically what it is. So when you write it out, and you have that n factorial over n minus r factorial from permutations, and still also divided by r factorial to account for the fact that the order doesn't matter. So. All right, so let me do an example. All right, let's say you are going to an ice cream parlor. Often I like to use Andy's Igloo, and you're going to order a shake from Andy's Igloo in Winter Haven. I know many of you don't live in Winter Haven, but Andy's Igloo is kind of a fixture of Winter Haven. Order a shake from Andy's Igloo. And let's say that there are 20 different flavors of ice cream. And the shake will be made with three flavors. Three different flavors. I should say different. That matters too. You can't have repetition in combinations just like you can't have repetition in permutations. Oh my gosh, it did it again. All right, so the shake will be made with three different flavors. And then if you think about this, the order that the three flavors get added doesn't matter. So if you think about it, it's a shake. It's all getting mixed up anyways. So when you're ordering your shake, let's say you want to order one that has chocolate ice cream, peanut butter ice cream, and banana ice cream in it. Chocolate, peanut butter, banana will make the same exact shake as banana, peanut butter, chocolate. So the order you put those three in doesn't matter. Permutations, the chocolate peanut butter banana was a different listing than banana peanut butter chocolate. Both combinations, those problems, switching the order doesn't change anything, so we don't need to count those. We don't need to count those switchings. You know, chocolate peanut butter banana, chocolate banana peanut butter, banana chocolate peanut butter, all those different arrangements don't need to get counted. So what we're going to do here is it is a combinations question. And from those 20 flavors of ice cream, we're choosing 3. So 20 factorial would tell you how many ways you can line up all 20 flavors of ice cream. Like if you were doing a display at Andy's Igloo and want to see how to line up the different ice creams, 20 factorial will tell you how many ways you can do that. But then you got to divide by 20 minus 3 factorial if you want to see how many permutations are possible when you choose 3 of the flavors. And in that case, like if you're trying to line them up for display, then maybe you want to know that. But we're not. We are making a milkshake. We don't care about order. We just care about what ingredients. So different ingredients make different combinations. So we got to further divide by 3 factorial to take that into account. That like chocolate, peanut butter, banana, you can make 6 different arrangements with those 3 flavors. So we're going to have to divide by 3 factorial or 6 to eliminate all those different arrangements of the same 3 things. So we've got 20 factorial over 17 factorial times 3 factorial. Oh my goodness, why is it still doing this? I need to talk to my husband about fixing that. That I need to get a new tablet. Not in the budget, but anyways. All right, 20 factorial over 17 factorial. What's going to happen is 17 on down is going to reduce out. So you don't even have to worry about that. 20 times 19 times 18, and then 17 down all the way down to 1 is going to reduce with this 17 factorial. And then 3 factorial is 3 times 2 times 1, or 6. 6 and 18 reduce down to 3. So you got 20 times 3 is 60 times 19 is 1,140. So you have 1,140 different milkshakes you can make if you choose 3 separate flavors of ice cream to put into the milkshake. So that's how many combinations are possible. That's the number of possible shakes. Now that can be done on your calculator too. Let's go ahead and pull up the calculator and see. The process for doing combinations on the calculator is very similar to the process for doing permutations on the calculator. So in show, pull up the calculator. I want to figure out number of combinations of 20 items. Choose. So if I go to the probability menu again, if I go to math, PRB, number 3 is in CR. Choose 3. So number of combinations of 20 items, choose 3. You hit enter, and voila, there you are. You get the same number. I'm trying to pull that over. Okay, there it is. But so we figured it out by hand on the slide, 1,140, and then on the calculator, just use that combinations function, and it figured it out for us. Okay, what do we got next? Let's see. We've got playing a card game, and 5 cards are being dealt. Player receives 5 cards. Okay, and in this situation, it's a standard deck of cards, 52 card deck. So they're dealing out cards. A player receives 5 cards. How many different ways can 3 kings and 2 queens be dealt? Okay, so think about this for a second. You know, you're going to have to be able to distinguish in your problems whether it's permutations or combinations. So you have to ask yourself, in the end, does the order of things matter? Well, in this one, after they've dealt you your cards, imagine them dealing your cards out to you face down. When you pick up your cards, you have no way of knowing necessarily what order they were dealt in. Or, I mean, I guess you could leave them in the order and pick it up and look, but it's really not going to matter. Like, as you play your hand, you can move your cards around, shuffle them, and it's still going to be the same hand. So a card hand stays the same when cards are merely shuffled. Like if you have your 5 cards in your hand and you just move them around, it's still the same card hand. So order doesn't matter. What does matter is whether or not you have different cards. So like if you have a king of spades, king of clubs, king of diamonds, that's different than having king of spades, king of clubs, king of hearts. So the only way to make it different is if you have very different cards. But saying, oh, I have king of clubs, king of spades, king of diamonds, and then switching them around and having king of spades, king of diamonds, king of clubs, that doesn't change your hand. The other players aren't going to care that you move them around within your own hand. Order doesn't matter. So this is a combinations problem, because you're looking at how many different ways can 3 kings and 2 queens be dealt. So let's see here. Okay, so this particular card hand, they're trying to be very specific and make sure that you have 3 kings and 2 queens. So in this problem, we're trying to find the combinations possible for 3 kings from the 4 in the deck and the 2 queens from the 4 in the deck. So this one's a little different. It is still a combinations problem because, again, not caring what order they're sitting in your hands, but you're specifically trying to figure out, all right, we want to make sure this person has a hand with 3 kings and 2 queens. So for the kings, we're giving them, we have 4 kings and we're only choosing 3. And for the queens, we have 4 queens, but we're only choosing 2. And when you see the word and, that means multiply. Okay, so you've basically got, let's see here. Let me put it up here. So you've got 4 factorial over 4 minus 3 factorial times 3 factorial for the first combination, times 4 factorial over 4 minus 2 factorial times 2 factorial for the second combination. So we got 4 factorial over 1 factorial 3 factorial times 4 factorial over 2 factorial 2 factorial equals, well, 1 factorial is just going to be 1. 4 factorial over 3 factorial is going to reduce down to just 4. And over here, 4 factorial over 2 factorial, you're going to be left with 4 times 3. And then 2 factorial, you're just going to be left with 2. And then you can do a little reducing. And you end up with 4 times 2 is 8, times 3 is 24. So you have 24 ways that you can deal 3 kings and 2 queens to somebody, given that you have 4 kings and 4 queens to begin with. So some of these can be a little tricky because they involve more than one step. They might involve more than just taking one combination. You might have to do some multiplying or something. Okay, Jamie has 7 CDs. Well, who cares around CDs anymore? That's a little outdated, isn't it? And wants to select 4 to take to work. The only CDs I really work with are audiobooks from the library. And even those are electronic now, but I have an old truck and only have a CD player. I don't have a way to play electronic books otherwise. Anyways, Jamie has 7 CDs, wants to select 4 to take to work. How many ways can you do this? You think about this for a second. Once he selects 4, he doesn't care what order they're in. Now he might care if what order he's going to listen to them later, but just that selection of putting them in the car, once he selects and goes to put the CDs in the car, the order doesn't matter. When order starts to matter is when you start ranking them for some reason, like best to worst, or top, how many weeks they're in the top charts, that kind of thing. But right now he's just grabbing 4. So if he picks up Bon Jovi first and Michael Jackson second, it doesn't matter if he switched it and put Michael Jackson first, Bon Jovi second, or whatever. I'm just coming up with some random names, but so this is a combinations problem. He has 7 items, choose 4. So he has to do 7 factorial over 7 minus 4 factorial times 4 factorial. So that's 7 factorial over 3 factorial times 4 factorial. I know 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. So the 4's reduce, 3's, 2's, 1's. This 1 doesn't really matter. 2 goes into 6 3 times. Oh, 3 and 3 reduce down to 1. So that leaves me with 7 times 5, or 35. So he has 35 ways that he can choose his listening music for work. All right, let's do one more. Nabisco is texting five cookies, 4 crackers, and 3 cereals. I'm just making up something here. It will mark it two cookies, 3 crackers, and 2 cereals. How many combinations are possible? Problem itself gives you a huge hint of what you're doing here. You're finding combinations. But you've got 3 different categories you have to work with here. Because you're working with cookies and crackers and cereals. So you got to figure out the number of combinations for cookies, the number of combinations for crackers, the number of combinations for cereals. And since it's joined by and, remember to multiply. Because you're not only finding out, well, how many ways can they market the 5 cookies, choose 2. How many ways can they market 4 cookies, choose 3. How many ways can they market 3 cereals, choose 2. But they're putting us all together in their marketing. So they're trying to see, well, how many marketing campaigns can they come up with when you put all of that together. So those ands, you got to multiply these combination results together. Let's see, you got 5 factorial over 5 minus 2 factorial times 2 factorial times, you got 4 factorial over 4 minus 3 factorial times 3 factorial times 3 factorial over 3 minus 2 factorial times 2 factorial. Alright, so you have 5 factorial over 3 factorial, 2 factorial times 4 factorial over 1 factorial, 3 factorial times 3 factorial over 1 factorial, 2 factorial. Since you're multiplying, you can put them all together in the same, like numerators together, denominators together, it doesn't really matter. But like, so here, like 3 factorial over 3 factorial reduces to 1. We really don't need to pay attention to the 1 factorials because dividing by 1 is just going to give us some result. But let's see here. 5 factorial over 3 factorial is going to leave us with 5 times 4. So that eliminates that because 3 on down will be reduced. 4 factorial over 2 factorial is going to leave us with 4 times 3 because 2 on down is going to be reduced. And on the bottom you still have 2 factorial, which is 2. Well, 2 goes into 4 2 times. So 5 times 2 is 10, times 4 is 40, times 3 is 120. Okay, so hopefully I didn't mess up anywhere in my calculations. Let's see, one more time I'll pull up the calculator and show you how to put that in. Let's clear that up. And in fact, if you want, you can put, you can do this. You can do parentheses, 5 combination 2, close parentheses, times parentheses, goes 4, oops, parentheses first, 4, combination 3, close parentheses, times parentheses, 3, combination 2. Enter. And it'll go ahead and just do it all for you. So, nice quick way of doing it. So there you go. So you get 120 different ways that Nabisco can put their marketing campaign together when you're looking at combinations of all of those. All right. Well, this wraps up your probability unit. I hope you had as much fun as I did. Maybe, maybe not. So there you go. So have fun. Make sure you learn all this. Practice, practice, practice. And then once you finish your test for this unit, when you come back, we'll be starting the unit on statistics. We're going to be doing a little tiny sampling of statistics for the last unit. Statistics and probability are connected. In fact, often if you take a statistics course, there's a lot of probability chapters in there too. So not totally unrelated to what we're doing, but a little different perspectives. So a lot of people usually like the statistics chapter. All right. Well, thank you again for joining us, and I will see you again soon.